Hi, it's Miss House. In this video, I'm going to show you how to graph the solution of the system of linear inequalities. Well, the first thing we have to do is graph these inequalities as though they were lines. So I'm going to start with the first one, and I'm going to just write it as a line. Y equals x plus 3. Now this is in the y equals mx plus b form, so my slope is 1, because remember there's an understood 1 here in front of the x, and my y-intercept is 3. So I'm going to use that concept to draw the line. Now, you could also find points on the line. So, for example, I could pick x to be 0 and 1, and then I could say y is 0 plus 3, which is 3. Y is 1 plus 3, which is 4, and you could plot those 2 points. So you don't have to do the slope-intercept form, but it is a way to graph a line. So if my y-intercept is 3, okay, and my slope is 1. Now remember, a slope of 1 is 1 over 1. That means up 1 and to the right 1. So we're going to rise 1 and run 1. So from this point, I'm going to go up 1 over 1, up 1 over 1, up 1 over 1. And these are additional points on my line. So I'm going to draw my line through those points. Okay? Now, because this says greater equal, I put a solid line. So let's go ahead and note both of these are going to be solid lines, because everything on the line is included when you have greater equal or less equal. You're going to put a solid line. If you've got greater or less, you're going to put a dashed line. So in the math palette, when you press the palette, it'll give you the keys look like this. Solid line is going to be default, and then there's a little dash line underneath that. So I needed a solid line. Now I need to pick a point on either side of this line, okay, to determine where is this greater than x plus 3. So now I'm going to go back to the original inequality. Y is greater than or equal to x plus 3. And I'm going to pick a point anywhere that is not on the line. So since it doesn't go through 0, 0, that's an easy one to do the arithmetic. So for y, I'll put a 0, and for x, I'll put a 0, and then I'm going to evaluate to see if this is true. Is 0 greater than or equal to 3? Well, that's a no. So instead of shading where the test point is, I shade the opposite side. So that means all of this gets shaded up here, and my math lab has a little bucket that you dump to do your shading. Okay, now that's just the solution to the first one. We have to do the other line. So let's do y equals 4 minus x. Now remember, I'm only looking at the equality to get my line, and then the inequality comes in when I do the test point. Now I'm going to rewrite this as negative x plus 4, because that allows me to put it in the y equals mx plus b form. My slope is a negative 1, my b is a 4. And again, you can make a chart and pick a couple of values for x. Let's see, 4 minus 0 is 4, 4 minus 1 is 3. So those are some points on the line. So you could do that. Or I could say my y-intercept is 4, and my slope is a negative 1. And when I have a slope of negative 1, that means negative 1 over 1. So I'm going to go down 1 and to the right 1. Now remember, a negative slope goes downhill. So from that blue dot, I'm going down one to the right one, down one to the right one. And all of these are going to be points on the line. So down and over, another point. Down and over, another point. And so now I draw in that line. Oops, sorry about that. Draw in this line like this. Okay. Now I need to test a point on that line. And look, once again, 0, 0 is not on that line. So I'm going to go with, and I'm going to write down the original, greater than or equal to 4 minus x. I'm going to test the point. That was our test point, 0, 0. I like that as a test point as long as the line doesn't go through that. You have to pick a point that's not on the line. So let's see, that's going to be 0 for y, greater than or equal to 4 minus x. Well, that's, 4 minus 0, my bad. Put a 0 there, because x and y are 0. 0 greater than or equal to 4, that's another no. So I have to shade on the opposite side from the test point. So I'm going to shade. I'm going to pick a different color so I can demonstrate to you here. Okay. Now, I've got an area where these overlap. Okay. These overlap in this section up above, and that's my actual solution. So this can't be shaded, okay, when I do it in my math lab. This can't be shaded, okay. Only that overlap is my solution. So in my math lab, you only want to dump once, okay, and you dump your paint, your shading in the area where they overlap. So you're going to have to sketch these on a little piece of paper to find the answer first, and then you can go into my math lab and shade this, just the section that is your solution. All right, let's do another one. Number 2, graph the solutions of the given system of linear inequalities. Now this time I want to make a note that this is a dashed line, because look, there's that less than, and this is a solid line. So the first one, y equals 5x minus 1. I'm going to the equal because I'm just doing the line. I have a slope of 5 and a y-intercept of -1. So my y-intercept is at -1. So go to the y and I plot a -1. And then my slope is 5. Now remember, a slope of 5 means 5 over 1. So that means up 5, because remember it's rise over run, right? So we go up or down first. It's positive, we go up. And then it's positive here, so we go to the right one. So from that first point on my y-axis, I go up 5. And then I go over 1, and that's where my point is. Once again, you may make a table of points. I'm going to go up 5 here, over 1 here. And you know what I could do? Look, -5 divided by -1 is equivalent to 5. So I could go down 5 and left 1. So I'm going to get another point down here in this first quadrant by going down 5, 1, 2, 3, 4, 5, and left 1. So look, there's another point too. All right, so I'm going to connect those. Whoops, missed it. Let me do it again. I don't have a ruler. And it is really important that your lines are very, very straight. In fact, I need to be careful here. That doesn't go through 0, 0, but it goes real close. So I'm not going to pick 0, 0. Now, I should be doing a dashed line. So for me, I can go back and just make this a dashed line. Take out some of the points like that. You need to use the key in MyMathLab that has the dashes on it, okay? The solid line will be up above it, and you're going to use the one with the dashes. So if you draw the solid line, no big deal. Just go over there and click on the dash line. It'll change it for you, okay? Now, I am reluctant to use 0, 0 because look how close it is. So pick anything you want as long as it's not on the line. So I'll just go over here and I'll pick this one. I'll pick 4, 0 for my test point. So my test point in the original inequality is going to be 4, 0. 4, 0. So remember, y is less than 5x minus 1. My x is 4, my y is 0. So 0 is less than 5 times 4 minus 1. 0 is less than 19, right? Because 20 minus 1. That is a true statement. So in this case, I am going to shade on that side where the test point was. So I'll go ahead and shade this in. Now remember, we're doing this on paper. You can't shade it on MyMathLab. You got to use some paper first. Okay. There's my shading for the first one. Now I'm looking for overlap, so I have to look at the second line. So look, the second line is y is less than or equal, and I'm going to do it as the equal right now because I want to just draw the line. So let's see. So y is equal to x plus 4. My slope is 1. My y-intercept is 4, or make a table. So y-intercept of 4, I'm going to go up here to 4. I'm going to put my point at 4, and a slope of 1 goes up 1 to the right 1, up 1 to the right 1, up 1 to the right 1, up 1 to the right 1. So you don't have to do that many points, but let's see. Let me draw that a little bit better. And again, MyMathLab is just going to draw it perfectly for you, right? Okay, now that was a solid line. Remember, we said because of this less equal, we put a solid line. Now, I can test the same test point, or I can pick any point that is not on that line. And this time, look, 0, 0 is clearly not on this second line. So I'm going to use 0, 0 as my test point. So I'll write down test point 0, 0. Okay, so go to the original. Y is less than or equal to x plus 4. 0 is less than or equal to 0 plus 4. 0 is less or equal to 4. That is a true statement. We shade on the side with the test point. So that's going to be shaded below this line. Okay. Everything that's below that line. Now what I'm looking for is where they overlap. Okay. So up here in this upper part, it's only blue. So that's not part of my answer. So that part shouldn't be shaded. Okay. Down here, in this section, I only see the yellow. So that's not part of my solution. So my actual solution is below both of the lines where you see shaded. Okay. So you would only dump in this region here inside of MyMathLab. Okay. Remember, you only dump once inside of MyMathLab. Now, I'm pretty sure you can dump and then click on the dump again and undump. So you can try it out. But basically, it's best just to do this on paper, get your answer, then put your answer into MyMathLab, which you should be doing anyway, right? You should be keeping a notebook of your work, and that way you won't have to worry about entering the wrong thing in MyMathLab. Do it right on your paper, and then just change over to MyMathLab. Okay, this is very similar to the ones we've done, so I'll skip this one for now. Same there. Now this one's a little different because of the format of the lines. So let's take a look at this. The first one is, line is going to be x is equal to 3y. And I'm going to go ahead and make a note. Both of these are going to be solid lines because you've got the equal to. Okay. X is equal to 3 times y. Now, this is not in either of the formats, so I'm just going to go ahead and make a table. X and y. Now, look, x is equal to 3 times y. Okay? X is equal to 3 times y. So if y is 1, x has to be 3. Look, 3 is equal to 3 times 1. 3 is equal to 3. That's true. Okay, pick another y. X is equal to 3 times that, so 6. Okay, now if you wanted to solve it for y, look, if you've got x equals 3y, you can divide by 3. So x divided by 3 is y. So look, same thing. Y is equal to x divided by 3. So if you divide 3 by 3, you get 1. You divide 6 by 3, you get 2. Make sure your points actually work in the equation, okay, before you graph your line. So I'm just going to graph these 2 points, 3, 1, and 6, 2. And I'm going to find a few more points. Look, I see the slope of that. Let's see. Make sure 3, 1, 6, 2. The slope of that is up 1 to the right 3. So I'm going to go up 1 to the right. I'm going to get another point there. I'm going to go down 1 to the left 3. Down 1 to the left 3. Down 1 to the left 3. In MyMathLab, you only have to have the 2 points. But for me, since I'm doing it manually. Now I need a solid line, so I'm going to try to hit all those dots going through there like that. Okay? All right, so that's the first one. Now, notice that this line went through 0, 0, because 0 is equal to 3 times 0. Cannot use that for a test point. I need to pick something that's clearly not on the line. For my test point, I'll pick 6, 0. Doesn't matter as long as it's not on the line. So my test point for this first one is 6, 0. Go to the original inequality. X is greater than 3y. Put in x is 6 is greater than or equal to 3 times 0. 6 is greater than or equal to 0. And that's a true statement. 6 is greater than 0. So this first line on my paper, I'm going to shade down here. Okay. Now, MyMathLab, again, don't shade in MyMathLab till you've decided which region it is that you need to shade. Looking at the next one, this line, x plus 3y is less than or equal to 9, is in standard form. That means it's very easy to find the intercepts. So I will make a table here and put a 0 for the y and a 0 for the x. So x plus 3, and by the way, I should have done this. I'm only doing the line. So let's do the equal to first. X plus 3 times 0 is equal to 9. Well, that's x plus 0 equals 9. So x is 9. So that's your x-intercept over here at 9. So put the first point there. Now, if y is 0, if x is 0, 0 plus 3y is equal to 9. 3y is equal to 9. Divide by 3. Y is equal to 3. So this is the point 0, 3, just like this was the point 9, 0. So 0, 3. 0, 3 is right here. So I'm going to connect those two points with the line. Let me make that not do that. There we go. And I get something like that. Let me do a little straighter if I can. There's my line. Now, notice that the original test point I picked, 6, 0, is not on that line, but it's really close. So I'm going to pick something that I know is not on that line. I want to get farther away, so I'm just going to go up here and I'm going to pick 6, 6. That's my test point. So my test point here is 6, 6. And I'm going to check it in the inequality. So that inequality is x plus 3y is less than or equal to 9. So 6 plus 3 times 6 is less than or equal to 9. Because remember, it's x plus 3y is less than or equal to 9. So that's 6 plus 18, that's 24, is less, well, that's not true, that's false. So I shade the side without the test point. So I'm going to have to shade below the line this time. So it's all of this and this and this. Now, where they overlap, okay, well, it's not here because, look, that's just blue. So that region won't be shaded when you do it in my math lab. Okay. And this region here is only yellow. So it's not that region there. They overlap in this region, oops, at the bottom. So the place that you would shade in my math lab is down here. So those two are in standard form. So we'll skip that one for now. Let's do this one because, look, we've got a vertical line because it's x only. And we have a horizontal line because it's a y only. Okay? So when I look at x equals 6, what that means is that every point on the line has an x of 6. And you can pick anything you want for your y's. So 6, 0, 6, 3, anything that has an x of 6, and look, it's solid and solid because of the underline, which means equal. So this is my first line, the vertical line through 6. Okay, and if you can remember that's a vertical line through 6, you don't even have to do a table of points. All right, then we're going to look at y is equal to -8. That's going to be a horizontal line through -8. But chart-wise, what it means is that you need some points where y is -8, and you can pick anything you want to. So I'll pick 0 and 3 again, this time for the x. So 0, -8 is here. And 3, -8 is here, and there it is. That's a horizontal line through -8. Now this time, 0, 0 is clearly not on either one of those lines because that's going to be my test point in the original inequalities. So for x is less than or equal to 6, using the point 0, 0, well, I can only put it in for the x, 0 less than or equal to 6. That is true. So for the vertical line, I shade where that is, and that's going to be on this side of the vertical line because I'm shading where the test point is true, and that's where it's true. Okay? Now, for the horizontal line, which is y is greater than or equal to -8, I put in a 0 for the y. Is 0 greater than or equal to -8? That is also true. So I shade again from the y, from the horizontal line, I shade above it. So this is the section where they overlap. And in this case, it turns out that I didn't have to worry about unshading any sections. So when you shade in my math lab, shade that to the left of the X line and to the above the Y line. There's another vertical and horizontal vertical. Okay, here we have a line that is not horizontal or vertical because it has both X and Y, and then we have a vertical line because of the X only. So 3X plus 4Y equals negative 12. That's in standard form. The easiest way to graph a line in standard form is to find the intercepts. So first I'll find the x-intercept by letting y be 0. 3x plus 4 times 0 is negative 12. Well, that's a 0. So 3x equals negative 12. Divide by 3. X is equal to negative 4. So there's my first point. My x-intercept is negative 4. Now for the y-intercept, I let x be 0. So 3 times 0 plus 4 times y is negative 12. That's a 0. 4y is negative 12. Divide by 4, both sides, y is negative 3. Now, this is a dashed line because of this just being less than. So I plot those 2 points, negative 4, 0, and 0, negative 3. And when I draw my line, I'm going to draw it as a dashed line. And you do the same thing, okay, inside of my math lab. Use the dashed line. It'll have a solid here, then it'll have a dashed. Use the dashed line for that line. Now I need to pick a test point for the first one. Look, 0, 0 is not on that line. So I'm going to go to my original inequality. 3 times 0 plus 4 times 0 is supposed to be less than negative 12. 0 less than negative 12 is a false statement. 0 is bigger than a negative 12. $0 is better than owing $12, right? So I do not shade where that test point is. I shade on the other side, which is down here. Okay, down here. Now my second line is a vertical line. I know that because X only. That means when I make my line X is equal negative 3, X has to be negative 3 for all the points, right? Or I can just say that's a vertical line through negative 3, and it is a solid line because of the greater than equal to. So negative 3, solid line. Now, you can also pick a couple of points. So negative 3, 0, negative 3, 2, and then you can connect those points. But recognizing that x equals negative 3 is a vertical line is really important to remember. Now I've got to check in x is greater than or equal to negative 3. I'm going to pick that same test point, okay? I'm going to test 0, 0. It's not on that line. So if I'm testing 0, 0, in that point, x is 0. So 0 greater than or equal to negative 3 happens to be true. So for this line, I shade on the side where the test point is. So that's this side. So I shade over here. And look where the overlap is. The overlap is this section, so that's the section that you would shade in my math lab. So for my drawing to be accurate, I have to get rid of all this stuff here, and I have to get rid of all this stuff here, because the only place where they are both true is this section here to the right of the vertical line and below the dashed line. That's where you're going to dump your little bucket in my math lab. I can't remember exactly what it looks like, but it looks like a little bucket, and you're going to dump it in that area only. So this is a good overview of how to graph inequalities systems, okay? That means they both have to be true at the same time, and that's why the solution is where the graphs overlap.